Hello guys and welcome in study 101.1 led by Abdurrahman Makrami and Omar Makram. Okay, now this video is about the extraction, how we will do it. So it's pretty easy but long. Okay, this is our sheet. We have edited so many times, that's why we have been, stalling. Okay, so we have changed it and some potential factors here. I'll say them. So I extracted this paper in the previous video, so I just felt like I don't have much time to re-extract it once again in front of you, but I calculated how much time did I need. So I needed about an hour and a half to extract one paper, which is pretty long time. So we will begin. I'll begin with number 4, study number 4. This is the title, the author, year, DOI. Those will be provided in the sheet where you extract them. So you don't need to extract those data, except if something of them is missing. You will have to extract it. But don't worry, we will provide you with that. Number of studies in the first plot. First of all, which first plot do we choose to extract? Simply, we choose the first plot which has the maximum number of RCTs. So what if the study contains 30 RCTs and all the first plots are less than 30, 29, 28, 20, we will choose the one with the 29, the highest number of RCTs present. What if we have two first plots containing 29 RCT? Which one will we choose? We will choose the one containing the first one to contain the highest number of RCTs. So this is our rule. We choose the first plot containing the highest RCTs in the systematic review or meta-analysis. So here we have 4 first plots here, and I think 3 first plots here. Here we have each one 4, and the upper one is 6, so we won't include those one because we need the first plot at least to contain 10 RCTs. Here A, B, C, D, A and C, A and D, I think they have 10 RCTs. We will choose, of course, A because it came before D. A is about death. The outcome is death. How will we extract data here? Don't worry about it. We'll just write now the number of RCTs present in the first plot. You can calculate. You can count them once again to make sure they are 10. So I wrote here 10 and fixed or random effects. This is in the analysis section. You will go here. You may search for it. Write fixed for an example. Oh, okay. Here. We performed analysis for the primary endpoint according to a fixed effect model, which means the analysis was fixed model. So I wrote fixed. Now our first tab is finished for the first study. Then we have here the potential factors. What are the potential factors here? We write the ID, the impact factor. How can we find the impact factor? That's pretty easy. You just go into AKB. This is for the Egyptians and the Vietnamese. I really don't know how you may do it, but it's pretty easy for the Egyptians, and each team has at least 2 Egyptians. So we wait for AKB to work while we search for Schemago index here. This is Schemago index. That's pretty easy. That's not for Schemago. This is for getting papers like Science Hub. You may use it. Science Hub, by the way, is not working by CC or BZ. It's working by TW. Only TW is working. Okay, let's move on till we search for Schemago index. Yep. Alright, Schemago index. And here is Egyptian Knowledge Bank. We will sign in order to see the sources. My internet connection is sick. So, okay, we'll move on till they open up. The Egan index, or the Egan, I don't know how to pronounce it. So it's, I don't know what it is. So we asked Dr. Roy, and till now he didn't answer us. So number of authors. This is pretty easy. Count them here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So they are 9. Number of extractors. Let's see. Okay. 3 trained investigators independently searched. Okay, they searched. Okay, they use the keyword blah 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 and so many words. Okay, they didn't mention anything about the extraction here, how it was done. Okay, selection, they selected blah blah blah. Okay, validity assessment. Okay, no problem. This is by Cochrane collaboration, the method for collaboration. Study characteristics. Okay, statistical method. There is nothing about the number of extractors. You may search for it once again. First author, what is his country and the H index and the corresponding author? You may find that the first author is the same as the corresponding author, like this study. Here we see the first author is Antonio Abate. And or Abate, I don't know how to pronounce it. So where is the corresponding author? We may search for it in another. Okay. No, not here. This is the search strategy, which is important for Amster. Yes, here. Reprint requests and corresponders, Dr. Antonio. So he's the same one working in Virginia, blah blah blah. Okay, we will copy his name to get the H endings and so on. Let's see. Okay, Egyptian Knowledge Bank, here is. Sign in. Schemago index, yes, this is the website. Okay, Antonio Abate, how we will find out who is this man? So we will just go into Google Scholar. This is pretty easy. Okay, the Schemago, we will just write the title or the publisher name. The publisher name is the journal name. So I write the title, which is easier for me here. This is Schemago. I think we may add a column for the, oh, no result were found. Oh, I got it once. Maybe it's, okay. Let's see what we have here. Okay, I'll search for it once again. No problem. I got the name of the publisher here. Here's Dr. Red. H index is 59. So we wrote here 59. Yes, and the potential factors here. H index 59. The country is the USA. You may just know it from cardiology. He just mentioned it in his CV on Google. You may just find it. Okay, here is Egyptian Knowledge Bank. We'll get into the old sources and we will see Scopus. We need Scopus. Okay, here Dr. Abate Antonio is in Virginia, which is in the USA. Okay, so we got everything about this man here. Okay, does the author have more or equal to RCTs in the included systematic review? We will see. We'll just write Abate and we will see. So we will get into the references directly. No, okay. Let's see. Here, he has one. Published in 2003. We will make sure that he's the one. Second one. Third one. Fourth. Okay, let's make it again. So, Abate A, which means Antonio Abate. Okay, we will copy that one. I'm so stupid. I made something stupid. Okay, I can get it from the allof. This one, I think. Yes, okay. I could have typed again. Okay, what we're gonna do is that we search for the name, which is not present. I think I may just try to show all the articles of him, just to make a good search. Those are all the articles about it. We will see. I think I was wrong when I wrote now. Okay, let's search. Oh, okay. One. Let's continue counting. This is another one, Abate A, which means Antonio. This man has so many publications. Not his. The other one, we have two other. Also Abate A. We have here a point, we may just remove it in the search. No, it's not present. And the last one, which is, yes, this one. We open, yes. Okay, so he has two. He has two articles. So I was wrong, so write yes. Yes. Is the same. And okay, let's see the impact factor in Scopus. This is the remaining thing in this tab, Scopus, and we need the title here. Okay, here it is. Journal of American College of Cardiology. We'll search for it in Escamago and we'll see. So, okay, the impact factor is 5.34. I think I wrote it right. 5.39. Oh, that was wrong. Okay, 5.34. Okay, and Schemago is, we will take this a copy, put it here. I searched for it before. Yes, here. H index is 369. We don't need that. We just need the Schemago, which is in 11.488 in 2016. 11.488, or there 288, 488. So I was right. Let's move on. The second step is a bit confusing. You may not like it. Okay, data. We will begin in data in the systematic review and meta-analysis. We will check the data. So you write the data present in the systematic review and meta-analysis, just like that. We will just make sure that we are working right, which means that we are, we have the intervention group and this is the placebo or control group. Don't mix them. You have to decide which one is the interventional and which one is the placebo or control. So we have here a control group and here an interventional group. We will write these data right here. 64818703210, and the total is 149, 182, 109, 44, 107, 82, then 18, 96, 32, 25, 42, and you just check the data here again. I'll check it. 17, 8, 9, 5, 84, 2, 22, 110, 151, 183, 103, 39, 1084, 18, 105, 34, 19, 45. Okay, don't make that. I make that because I'm sure I just made that so many times and I'm sure I won't make a mistake in it. So when you check the data, don't do it like that. You may check the the events and total for every study. Okay, so then you will see which measurement tool they used. Here they used the relative risk. Yes, I think they used the relative risk. They wrote it somewhere. Maybe here. Okay, so you will search for it. I don't know where I found it. Pretty sure it was somewhere in. Yes, here. Relative risk. For death, it was relative risk. Okay, so pretty good. So we'll write the final result here. We'll write 0.49, relative risk 0.49, the pooled effects, lower confidence interval and higher confidence or the upper confidence interval here, and we're good to go. So we will now check the data in the RCT itself. Then we will calculate the relative risk here. How we will calculate it? It's so easy. Just get MetCalc calculator, relative risk. You write all the data here. What will you like? What will you write? You will write the event, the total for the first group. You will summate them. You will just make summation 6 plus 4, 10, 18, 19, then 87, and so on. And here also you will write the total. Okay, so what are the bad outcomes? What are the bad outcomes and what are the good outcomes? The bad outcomes are the events, and good outcomes is the total. No, you will subtract 149 minus 6 to get the good outcomes. So the event here is the bad outcome. So you will write, for example, 6, and here is 149. 149 minus 6, which is 143. And the control group, okay, we have 17 event, which is the bad outcome. What is the good outcome? 151? No, 151 minus 17. I'm not good at math, so I will write that. 151 minus 17, which is 134. I'll write that, 134. Test. Okay, so the relative risk is 0.3577. This is for the first study, 0.33. Okay, the confidence interval, 0.13, the lower. No, that's not right. I think I made some mistake. Let's check the data again. So the number of bad is 6 in the interventional group. Then my, yes, 149 minus 6. Okay, and the positive outcome here is 17 and minus, okay, we will remove 1 then. Okay, yes, it's pretty good. It's pretty right. Except if they are not using the relative risk. Did they use odds ratio or relative risk? I'm not sure. Let's see the odds ratio. I calculated using the odds ratio and we'll see. Okay, cases with positive or bad outcomes. Here is 6 and here is 17. And we said in the exposed group it was 143, I think. And in the control group they were 134. Yes, let's test them. Okay, so they are now right. 0.13, here is 0.1266, which is 0.13, and 0.86. So I will edit this into odds ratio. So I did that for only one RCT, but please, you won't do that. We did that in the past, but now we will summate the events, all the events, and submit the totals, subtract them from the events to get the good outcomes. Here also we will do that, and here also we'll do that in the intervention and placebo. Then we will get into MedCalc odds ratio calculator and get the pooled effects here. If they are right or wrong. If they are wrong, please highlight them in red. If they are right, please highlight them in green. So you highlight them in green, like that, or highlight them in red. I don't think that's possible or so. So we'll just check if they are 0.49, 0.26, 0.94. That's all you do. How do you get these data from the RCT? This is another question. So we have, for example, ALKK. This is a study which is in the reference number 21. I want the link. Yes. 21. We will get to it. You can just get the data from the abstract if you can. If you can get them from the abstract, just do it. Okay. Here. No, it's downloaded. No problem. Here it is. So we'll search for the death outcome. Let's okay, here. Death. 1 angioplasty and 5 in the medical therapy. Is that right? I don't know. This is until 1 year after randomization. We seek the, here we have 6 years of follow-up, so we will search for another thing. Long-term follow-up. So we search for the long-term follow-up, okay? So do you think that we observed 17 deaths in the conservative group? That was right. And 6 in the angioplasty group. That was also right. So now we will write 17 and 6, which is right here. 17 in the conservative and 6 in the interventional. And we will see how many patients did we have. In the angioplasty we had 149, which is here, and in the control we had 151, which is right here. So you will check every article, each RCT. So just like that, you will see Brave 2, it's here. You will see Brave 2 study number 18, Decopy number 19, and so on. You will search for it using Google, using PubMed, using anything. Just get it. Just get the data right. And you can calculate the data here. That was for the value check. The quality assessment is for Amstar checklist, which is pretty easy. It's just longer than the old one. This is the new one published in 2017, I think in September. So I will get into it. just to let you know that there is here explanation. The explanation here is so good. Did the research questions and inclusion criteria for the review include components of PICO? What's PICO? You may just read that in the Cochrane Handbook of Systematic Reviews and Meta-Analysis. It's so interesting. So, if you say yes, they should have said the population, the intervention, comparator group, and the outcome. They have said them. Okay, and optional time frame for follow-up? Yes, they provided it in this study. We are talking about this study. Yes, they provided the time frame for follow-up. Anyways, you just say yes or no. And you write yes or no, because we have partial yes, and we don't have a final Amster number or count like the other Amster checklist. Why? Because here we have yes, partial yes, and no, and here we have no meta-analysis, another option, and so on. But then the last one we had just yes or no. So, second one, did the report of the review contain an explicit statement that the review methods were established prior to the conduct? Oh my god, you just have to know it. If they said anything about the inclusion and exclusion criteria, for partial yes, you should include all the following. All the following should be included in the systematic review. Did they have a review question, a search strategy? Yes, they had one. Here is the search strategy. Please search for every single word in the systematic review to make sure that everything is right. That's why it took me an hour and a half just to make sure that everything is right. I sometimes read the article as a whole, not reading, of course, just viewing the article. I, I see, okay, 10 studies, number of patients I have here, randomization allocated, okay, 2 and 2, they are the two groups, okay. Okay, so just from the abstract, I knew that they had a plan, that they had a protocol. They had a protocol, by the way. Okay, so I just read, I see the methods. Okay, 3 trained investigators did what? Did the searching and screening, but they didn't do the extraction. They didn't say anything about the extraction. So I see the inclusion criteria, the exclusion criteria. Okay, they made a validity assessment, the attrition bias, allocation concealment, performance detection. Okay, that's good. So they used Cochrane um, Cochrane method of risk assessment. And they had study characteristics, longest follow-up available, and so on. They saw the left ventricular ejection fraction, the end systolic volume index, the ventricular end diastolic volume index, and so on. You just see those things, and please make sure that you read the abbreviations and know it. If you need anything, there is always a table for the abbreviation and acronyms, okay? I don't think we may, just the video will be too long for us to say anything about Amster, so you may just read it here, and if you need any other help, and I can make a video about only Amster if you need. This is pretty easy. There are 16 questions which you can handle them. And thanks for watching. Yes, you say here, questions here, they have yes, no, or no meta-analysis. So if we can't just here say that there is no meta-analysis, this is inappropriate in our study because we include meta-analysis with first plot. There must be a first plot. Okay, so don't ever choose that option. Okay, so if you have any questions, just ask. And if you have anything about the Eigen index, please tell me. And if you found any other error I have made in this extraction, just talk to me and tell me that I have found an error and so on, and I'll give you a bonus. And search for the number of extractors. I didn't find them anyways, and nothing. And thanks.